Well, with the desert at the LHC, with nothing but the Higgs is something that's new, and only one Higgs. Uh, the Muon collider now, I think, is the most desired LHC follow-on, and it's also the most difficult, particularly at low to medium energy. At high energy, we've got the Lorentz time dilation, but at low to medium energy, to keep the stuff around long enough to be able to cool it and accelerate it is the major challenge. So what we're proposing is a simple method to perturb the magnetic scalar Lorentz potential of this particular mode of the neutrino scattering matrix with an external magnetic field, and this supposedly will break the symmetry of the topological degeneracy, the topological ordering that we have in the neutrino wave function, and shift the phase of one of the wave function components relative to the other two. So it's the virtual wave function component that we're trying to use to prevent the neutrino from manifesting and thereby sustain the muon lifetime. So there's three assumptions in the model we're using: the geometry, the vacuum wave function, which we're using the 3D polyalgebra of space for the vacuum wave function, and then we have to assign fields to the geometry, and we do that with the electromagnetic coupling constant. The four fundamental constants that define alpha permit assigning the appropriate flux quantity to the wave function components, and then we can calculate the interaction impedance networks. And this is important because this is what governs the flow of the amplitude and phase of the flow of energy. And then we have to define a mass gap, a lightest rest mass particle with both with electromagnetic fields to couple to the photon. So given that, we can generate a scattering matrix, as you can see here, with the 8-component wave functions, the product of the two 8-component wave functions. The Dirac wave function is electric charge and magnetic moment, and we've completed it. We've taken it to the maximum, the largest division algebra. So the geometric product here, it changes dimensionality. It doesn't multiply numbers or symbols. It multiplies dimensionalities. So this is dynamic supersymmetry. We're mixing bosons and fermions. What comes out is a 6D phase space, as you can see here, when we multiply the topological dual of electric charge, the magnetic charge. When we multiply a couple magnetic charges together, we get something that's 6 dimensions. It's 3 space and 3 phase, and time is the integral of phase. So if you do that integral, you collapse the phase space to flat 4D Minkowski spacetime. So here we see the muon and the neutrino scattering matrices. I've pulled the neutrino scattering matrix out from these items that were pointed out here, with the diagonal modes, the eigenmodes, and also this scalar Lorentz mode that we'd like to influence to perturb to enhance the lifetime. So the neutrino wave function we described in a previous talk, it's just the photon topologically protected by magnetic charge. And a similar approach for the muon adds a vector magnetic flux quantum to the 2-component electron. So adding these degrees of freedom to the photon and electron, we get the neutrino and the muon. And you can see here the muon is a scalar vector and an axial vector. Neutrinos vector, axial vector, and trivector. They share the vector and the axial vector. This is the V minus A coupling. In addition to having the geometric representation lost in physics, we also lost the concept of impedance matching. And so when we include this concept, then we can calculate these networks. And here you can see the correlation between the unstable particle lifetimes, or the coherence lengths, the causal boundary, and the nodes of the impedance network. The impedances have to be matched for the energy flow that happens in decoherence. So the method we're using again is we perturb the scalar Lorentz mode with an external magnetic field to break the symmetry of the topological degeneracy, to shift the phase of one of the virtual neutrino wave function components relative to the others, to keep it decoherent, unable to manifest, and thus we sustain the lifetime. And ideally, the experiment would run parasitic to the g-2 operations. So I hope to be able to meet and talk with you at the conference, and thank you very much for looking.